so far we've seen various phenomena. We saw day-night, we saw shadows, we saw the temperature changes during the day, we saw the sun's position changing during the day, and we saw the star's position changing during the night around the pole star. They've been explained by both the geocentric and the heliocentric theories.
Right.
So the aspects of the geocentric and heliocentric theories we've used so far in our explanations are the sun revolving around the earth under the geocentric theory, the dome of stars revolving around the pole star, and the earth being stationary. These are the three things we needed. And let's see how they explain all of those. If we have the sun revolving and the earth being stationary, we can explain day and night as we saw, we can explain shadows, we can explain temperature, and we can explain the sun's position changing during the day. For the star's position changing at night, we need a dome of stars which revolve around the pole star.
Yeah.
And the earth being stationary.
Yeah, and the axis of rotation passes
through the pole star.
Yeah.
In the heliocentric theory, the earth's rotation explains all of these observational generalizations.
And once again, the axis of rotation is whether it is the dome rotating or the earth rotating through the pole star.
Through the pole star,
right.
So now these are all 24-hour cycles. So now let's move on to yearly cycles.
Yeah. 365 days.
365 and a bit.
Yeah.
Okay. And let's take two phenomena. One is the north-south sun position change, and the other is seasons.
Yeah.
We'll explain what each of these.
Seasons I know, but what is the north-south?
Yeah.
Isn't it east-west?
That's in a day there's east-west. In a year there's a north-south movement, and I'll show you what that means. So assume this is where you are, and where you're looking.
That's horizon line.
This is the horizon line.
Okay.
And you're looking at it. At one point of the year, you'll see the sun over here.
Yeah.
Right? The center of the sun will be there. It'll rise like this. This is. Then as you go along, so just to explain, I'm looking at it over here. That's the east. Straight ahead of me is the east, and behind me is the west.
Okay.
Okay. And so what you'll see here, and this direction is north, and this direction is south. So what you see at one point of the year, the sun will be here. Then the sun will move here, and the center of the sun is what these lines represent. It will move here, 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 and then at some point it will start reversing direction.
Okay, so you're saying if your house is here,
yeah,
this is the house, and you are looking at the house and the sunrise from there. And you're saying that you will be seeing the sun moving away from the house.
Yeah.
And then coming back.
The rising of the sun.
Rising of the sun will keep shifting.
Will she keep shifting?
Yeah. And in the north, south.
North. This is the north-south direction, and the sun will move like this on a daily basis.
Right.
That's the daily cycle.
Yeah. So the sun here will be moving like this, and there it will be moving like this.
Yeah.
Right. The sunset will also be shifting in the north-south direction.
Yeah.
Okay.
Both the sunrise and the sunset.
Right. That seems to. So that means the shadow will also change.
Yeah.
In the north-south direction, and the sun is moving.
Yeah. But we're not concerned with the shadow.
Okay.
So how can we explain this using the geocentric theory?
Okay. So well, one way of explaining that will be to say exactly that's what happens. The sun oscillates between the north and south. So in addition to this movement, which is east-west, the sun will also do this, oscillate.
Okay. So let's draw that for some clarity. You have this as the earth.
Okay.
And this is the geocentric theory, so the sun is revolving around here. Let's assume we're looking at, this is the north and this is the south of the earth.
Okay. And this is the east and west?
Sure. That doesn't matter. East could be there also.
Right. The sun is doing this.
The sun is doing this.
Yeah. Oh, now you're shifted. This is the east and this is the east.
No, the sun is not doing this. The sun is going like this, out of the mist.
Oh, okay. Like this.
Yeah.
Okay.
The sun is going like
right.
This. Okay. And
also this is not.
This is not.
Yeah.
The movement of the sun.
Yeah.
The sun is coming.
You cannot draw it.
Yeah, you can't draw it.
Yeah.
The sun is going like
this.
Right. So while the sun is going like that, it also moves north. So assume you are this person here.
Right.
At this point, the sun is like straight in front of you,
Mm-hmm.
right? Now the sun moves here,
Mm.
and the sun is
Now
on top
towards
of
the north.
Yeah, you'll see it higher up.
Right.
And then it will start coming down,
Yeah.
and then at some point you'll see it below
Yeah.
you.
Not higher up.
Higher. You'll see it in
You'll
the
be
south.
here, and then you'll see it here.
Yeah,
The sun is oscillating between north and south.
yeah, yeah,
That will work.
yeah.
Yeah.
So this will result in this. Okay.
Yeah.
However, so this is an oscillation up and down.
Uh-huh.
How Ptolemy explained it,
Mhm.
which works in the same way, is a cycle. So the sun doesn't go up and down like this.
Mhm.
The sun goes like into the board like this. Sorry, into the board like this.
Yeah.
And
Yeah.
like this.
That's right. This will do it. Then you will, when you do this,
Yeah.
it's down, it is up, down.
Yeah.
Except you don't see
Yeah.
that.
It could
can
either
also-
go. It could either go this way or it could go this way.
Yeah, or this way. Yeah, that's.
Yeah.
If you go this way,
Yeah.
it is top, down,
Yeah.
but you don't see the sun's oscillation this way.
Yeah.
Because, sun is closer, sun is far
That
away. you
doesn't
don't
make
see
a
that.
difference.
Yeah,
Yeah.
okay. But instantly you will get an elliptical orbit if you do that.
Ah.
If the sun is doing this,
Ah.
you also get the elliptical orbit.
Okay.
So that's circular orbit.
Okay.
Okay.
So that's besides.
Yeah, yeah. Doesn't
The movement here is what we're interested in is the up-down movement.
Okay.
Okay. And so the epicycle idea is that it moves in circular.
Mhm.
There's a circular movement and not a straight line.
So the sun goes round the earth
Hmm.
like this
Yeah.
once a day,
Yeah.
and it also does the other one.
The sun. Here the sun goes like this.
Yeah.
Around
Okay.
here.
Right.
The sun goes around the earth like this.
Okay.
And
Can you also
it-
show the up and down movement or epicycle movement in this orbit?
Okay.
So
the sun is going
How-
like this,
Huh.
and at the same time, it is also going like this. So while the sun is going like this, it is also going like this.
yeah. So it's,
While it is
so the sun is going like this, and then it'll move up, and then it'll come down. It's like a spiral almost.
Yeah. Yeah, you'll be like,
Okay, so the sun is
Yeah.
here, then it'll move here, and it'll come back here, and it'll move here. There's some sort of spiral type movement, is what you'll see. If you were looking at it as an alien from over here, that's what you would see, the sun doing. Okay, even though these are two separate motions, when you put them together, it looks like a spiral going on. Okay. So
how do you explain
geocentric
seasons
theory
with that?
can explain
Yeah.
the seasons.
No.
It can explain the north-south position.
north-south movement.
Yeah.
Yeah.
For the seasons, so assume you are standing here.
Wait, let me raise this so that it's easier to see what's going on. So we're going to use the oscillation. That's easier. Epicyclic oscillation, have the same
It
type.
appears the same, especially when you're looking at it
Yeah.
like this. So the sun is here,
Mm,
and you are standing here
mm.
on the earth. Where here, so what is happening? The sun's rays are coming like this, right?
Yeah.
So they cover this area.
It's because it is perpendicular.
It's
Yeah.
perpendicular.
Right.
Now, when the sun is here,
Mm.
the sun's rays cover much larger area, so it go all the way to there,
Right.
right? And so it cover this
And if
area.
it is here, it'll be even more.
Yeah,
This much of area.
yeah. So the same amount of heat, the
Yeah.
same amount of light rays,
Yeah.
which results in heat, will cover a much larger area when it's here and here than when it's up here.
Right. So this oscillation will
This
also
is
give you
yeah.
summer
So
and
this
winter.
is summer
Mm.
for this person,
Yeah.
and this is winter for this person,
Right.
and this is something in between.
Yeah.
Okay.
And
So-
it'll be the reverse case for the people who are in the southern hemisphere.
Yeah.
Yeah.
So seasons. That's actually a separate phenomenon.
Yeah.
That it's summer in the northern hemisphere while it's winter in the southern hemisphere, and this explains that as well.
Yeah. So the basic idea that you're suggesting is the apparent effect of the sun moving to the south and west in a yearly fashion
Yeah.
will also give you the effect of seasons.
Yeah.
Right.
South and north. Yeah.
South and-
north.
South and north, that's
Yeah,
right.
That's
Not-
summer winter. That's
Oh, okay. I thought
Yeah.
south and north.
Yeah.
Okay.
Yeah.
And this is winter.
Yeah.
Okay. All right.
Or actually the other way, but that doesn't matter.
Yeah.
So now let's try explaining the north-south position of the sun using heliocentric.
Heliocentric theory. Let
for that.
me try explaining that.
Okay.
Okay. So let me take this model. This is the Earth. So what you said was this is the sun.
Yeah.
Okay. You said the sun is going up and down.
Hmm. Yeah.
right? And the Earth is stationary.
Yeah.
But suppose you don't do anything to the sun, how do you get this effect? You can do this. Okay, if the Earth does this,
Yeah.
then you get the same oscillation effect. Right?
Yeah. So if this is, I think it'd be easier to put the sun like this.
Right.
So what you'll see here is that the sun will be below you,
Right.
and,
now
here the
above.
sun will be above.
Below meaning this is now towards
Yeah,
the north.
above, no, towards
this
the
is
north, now it's
south.
towards the south.
Right.
Yeah.
So if the Earth is rotating,
Yeah.
and at the same time is also
There's a
doing
wobble.
this, so it'll kind of
Yeah.
wobble.
But the wobble is a 365-day cycle. You won't
Yeah,
see it every day.
That's right.
While that is a
You will get all that summer and winter as well
yeah.
as the
So
shift.
in this case, what we are suggesting is a heliocentric should have Earth rotation plus a wobble.
Wobble.
And let's just add in the stuff for the geocentric.
Yeah.
Geocentric requires epicycle,
Epicycle.
or oscillation.
Or oscillation. Yeah.
One of these two. So wobble, and these are 365-day. And this is also a 365-day cycle.
Yeah.
So now what we've added into heliocentric theory is this weird wobble. So it
Right.
goes
So
like
this wobble. Yeah.
right?
Yeah.
So, but there's a problem
But it'll
there.
be like, yeah.
But there's a problem there.
What's the problem?
Remember we explained the star's position
Right.
in heliocentric theory through the Earth's rotation, saying that the axis of the Earth should pass through the pole star.
So here's the pole star.
Here's the pole star.
Oh,
now,
if you do
now
the
if you do the wobble,
wobble.
now no longer is it every day passing through the same star.
You'll see the pole star shifting.
That will be a
its location.
different pole star
Right.
every time.
We don't want to do that.
So we can't have the wobble,
Yeah.
right? We need another way to get the same thing without the wobble.